Namaste. Today in this video we will be discussing about uncertainty in reasoning. Okay. It is remarkable that science began with the consideration of chance should become the most important object of human knowledge. The most vital question of life are really on the problem of probability. The theory of probabilities is at the bottom of nothing but common sense reduced to calculus. All of the time, agents are forced to make decisions based on incomplete information. Even when an agent sends the world to find out more information, it rarely finds out exact state of the world. Okay, so we can consider an example. A robot does not know exactly when the object is. Okay, the robot does not know exactly where the object is, but it moves. Yes, to find the object. That means uncertainty. And next example in our real life can be considered as a doctor does not know exactly what the wrong is with patient. So the doctor provides some medicine and test for a week. That means he start to say come after 1 week, come after 2 weeks, and he tests. He tests some of the medicine with our bodies, and if it changes positive, then he started to increase the dose of the medicine for some more days. But if not, it changes the medicine. So that is also uncertainty. That means doctor does not know exactly what the wrong is happening on the patient. Yes. So when intelligent must take decision, they have to use whatever information they have, considering the reasoning under uncertainty determining what is a true world based on observation on the world. It used in neural nets as bias for acting under uncertainty, where agent must make decisions about what action to take even though it cannot precisely predict the outcome of its action. It includes probability, so how to represent the world by making appropriate independence assumption, and so how to reason with such representation. Okay, so we include in uncertainty in reasoning, we include probability. Okay, so probability of A that can be represented as PA, for B, PB. Okay, so probability of A can be calculated. We have read probability theorem in probability and statistics. So it can be calculated as probability of occurrence of A divided by total number of sample. That means if we have head and tail in a coin, the probability of head to come is 1 by 2, that is 0.5, and that of tail is also 1 by 2, 0.5. That means there are two sample space, tail and head. Then the occurrence can be at least one at a one time. Yes, that means that is either head or tail. So that is 1 is the probability number of occurrence of head. And the total number of sample space is S. That means 1 by 2. If we toss for coin for one time, then the probability is 1 by 2 for head and tail. But for 2 times, it becomes 2 times it may come tail, 2 times it may come head, and 1 time tail, 1 time head, or 1 time head, 1 time tail. So there are 4 sample space, and the probability of 2 head at a time is 1 by 4. In this way we calculate the probability according to the sample space of the given population. So next one is conditional probability. Conditional probability. So probability of A when B given, that means there will be two events. Probability of A, okay, when B is given, that is P A B. Okay, it can be written as probability of A intersection B, that is A and B, divided by probability of B. Okay, probability of A when B given is probability of is equals to probability of A intersection B divided by probability of B. If B given A, then probability of A intersection B divided by PA. Okay, that is also written as PA slash B. Probability of A when B given. Okay, so this is conditional probability. Okay, let us consider an example. If PA intersection B is 0.2 and PB is 0.3, then probability of A when B given can be expressed as 0.2 divided by 0.3. It is 2 by 3. Yes, it is 0.666. Okay, so this is how we use conditional probability. And next one is, okay, independence. Okay, so independence, that means probability of A independence of B. That is probability of A when B given. If A and B are independent, then probability of A slash B is probability of A, because A and B are both independent space. Okay, and next one is joint probability. Okay, probability. Okay, LIT. Okay, so it completely specifies all belief in problem domain. It is an n dimension. Okay, n dimension, ND, n dimensional table with a probability in each cell of the state occurring. It is expressed as px1, x2, dot 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 xn, and instantiated as px1, x2, okay, dot 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 xn. So let us consider an example as p toothache. Okay, toothache and cavity. So the table can be cavity and cavity and toothache. Cavity and cavity, okay. Toothache and toothache. So 0.04, 0.01, 0.06, 0.86. Okay, and probability distribution. Next one is probability distribution. Okay, probability distribution. So distribution of probability of occurrence of the event is constructed in histogram. Okay, such example, PA equals to 0.1, PB equals to 0.4, okay, PC equals to 0.5. So you can construct a histogram for it. 0.1, okay, 0.4, 0.5. So the probability is represented in histogram in probability distribution, and the sum of the probability must be equals to 1. Okay, and the probability of the given object lies in between 0 and 1. So next one is Bayes theorem. Okay, so Bayes theorem. So Bayes theorem can be expressed as probability of A when B given is equals to probability of B by A into probability of A divided by probability of B. So we'll be discussing about this theorem in next videos. Thank you and bye bye.